In this video, we're going to learn how to identify trigonometric ratios when looking at right triangles. And this is to prepare you to be able to use SOH-CAH-TOA later to solve for missing sides and angles of right triangles. So your trig ratios are the ratios of the lengths of two sides of a right triangle. The three most common ratios are sine, cosine, and tangent. Now, we use some like SOH-CAH-TOA to help us remember how sine, cos, and tan are written. So, SOH-CAH-TOA, you can divide this into three different pieces. SOH, CAH, and TOA. SOH being used for sine, CAH being used for cos, and TOA being used for tan. And this shows you how to set up the ratios. So for SOH, it would be O over H, CAH, A over H, and TOA, O over A. You need to be able to use label the sides of a right triangle to do this. So remember, your hypotenuse is always across from the 90-degree angle. And then if you're looking at your angle, here are theta. Adjacent is going to be the side that's next to your angle or touching your angle. And the opposite side is going to be the one directly across the angle. Remember, your hypotenuse is always across the 90-degree angle. So when I'm labeling my triangles, I'm going to just use the letters H for hypotenuse, O for opposite, and A for adjacent. And then I will use the numbers that are on those sides to help me set up my trig ratios. So here we're going to find sine, cos, and tan for this triangle. Here we're using it for the angle R. So I'm going to label my angle R first, and then I'll label my sides. So angle R is here. Remember, your hypotenuse is always across the 90-degree angle. So I always start by labeling my hypotenuse, or my H. Then if you look at R, it's next to side 9. So it's adjacent to side 9, and it was opposite of side 12. So I labeled my letters O, H, and A so that I can use them when I'm doing SOH-CAH-TOA. So let's start with sine. For sine, you're using SOH. I like to write it as a fraction so you remember where O and H go. So for sine, we're using SOH. So that means sine R is going to be equal to opposite over hypotenuse. That's what that O and H means. So here our opposite is 12 and our hypotenuse is 15. We can simplify by dividing those by 3. This will come out to 4/5. So sine of angle R is equal to 4/5. Now, I'm going to continue. This time I'm going to find cos. So for cos, we're using CAH. And I write it as a fraction just to remember where things go. So cos of angle R is equal to A over H. A is 9 and H is 15. Here I can simplify. If I divide by 3, this comes out to 3/5. So cos of angle R is equal to 3/5. And then I'm also going to find my tangent. So for tangent, we use TOA. So remember SOH-CAH-TOA, and you'll be able to do this. So I'm using TOA. So tan of angle R is equal to O over A, which would be 12 over 9. If I divide those by 3, this comes out to 4/3. So the tangent of angle R is equal to 4/3. And now I have my 3 trig ratios for this triangle. Again, today we're just practicing writing our ratios. Later next week, we're going to learn how to actually use these ratios to solve for angles and sides of right triangles. In this next picture, we're going to find the trig ratios for angle X. So let's go ahead and label angle X. And remember, you start with your hypotenuse, which is across from that 90-degree angle. And then 3 is next to angle X, so it's adjacent, 1 is across, so it's opposite. I'm going to start by finding my sine trig ratio. So remember SOH-CAH-TOA. Let's start with SO. So sine of angle x is equal to O over h, which is 1 over root 10. Remember, you don't want a square root in the denominator. So I'm going to multiply by root 10 over root 10. So I get 1 root 10 over 10, or just root 10 over 10. So sine x is equal to root 10 over 10. Next, I'm going to find CA, which is cos. So SOH-CAH-TOA, I'm doing CA. So cos x is going to equal a over h, or 3 over root 10. Remember, you don't want a square root in the denominator. So I'm going to multiply by root 10 over root 10. That gives me 3 root 10 over 10. So cos x equals 3 root 10 over 10. Next, I'm going to find the tangent. So TOA. So tan x is equal to O over a, or 1 over 3. That's already simplified. And now I have my 3 trig ratios for this right triangle. In these next problems, we're just going to find 1 trig ratio for each triangle. So here in question 1, we're finding tan. So remember, when you're doing this, you should be thinking SOH-CAH-TOA. So if you're finding tan, you're using TOA. So tan of theta is going to equal over a. Well, I need to figure out what O and A are. So here's my angle. My hypotenuse would be the 10 inches. Adjacent would be 6 inches, and opposite would be 8 inches. So remember, in TOA, O goes on top, A goes on the bottom. And I can simplify this. If I divide by 2, it comes out to 4/3. So tan theta is equal to 4/3. In our next picture, we're finding sine. So we're using SO. So here my hypotenuse is 17. This is my angle. So 8 would be opposite the angle. 15 would be adjacent to the angle. Always mark your angle so you know what you're comparing it to. So for SO, it would be sine theta equals O over h. O is 8 and h is 17. That can't be simplified, so I'm just going to leave my answer like that. Next is cos, so we're using CA. My angle's here. I always identify my hypotenuse first. 12 is adjacent because it's touching our angle theta, and 35 would be opposite. So next, we are going to fill in. So we have cos theta equals a over h, which would be 12 over 37. That's already simplified, so I'm just going to leave my answer like that. Next, we're doing tan theta. Tan is TOA. So I identify my hypotenuse first. Here's my theta. So 2 would be adjacent, square root of 6 would be opposite. So I have tan theta equals O over a, which would be square root of 6 over 2. There's not a root in the denominator, so it's okay to leave this one like that. So tan theta equals square root of 6 over 2. In our next problem, we're doing sine. So my hypotenuse is 5. Here's my theta. So square root of 17 is adjacent because it's touching my theta. 2 root 2 would be opposite. So sine theta equals over h would be 2 root 2 over 5. Again, this one's fine because there's not a square root in the denominator. In our last problem there, we're doing cos, so that's CA. So I'm going to start by labeling my sides. Here's my theta, so 16 is adjacent because it's touching that, and 12 would be opposite. For CAH, we're using adjacent and hypotenuse, so it would be 16 over 20. Let me rewrite this. So cos theta would equal 16 over 20. I can divide this by 4, and that comes out to 4/5. So cos theta is equal to 4/5. So in this video, we just practiced identifying our trig ratios for our triangles. Remember, you're using the phrase SOH-CAH-TOA to help you. So is for sine, meaning for sine you have O over H. CAH is for cos, meaning for cos you have A over H. And TOA is for tan, where you do opposite over adjacent. Remember, H is hypotenuse, O is opposite, A is adjacent. Your hypotenuse is always across the 90-degree angle, and adjacent is the angle or the side that's touching or next to your angle.